But thank you so much for joining us today. I think this group is really excited to hear from you. And we actually have, I know at least one student who's planning on attending UAH. So,
Awesome. Okay.
yeah.
Yeah. So I've tried to set things up for I'm definitely obligated to try to sell UAH, but just so everybody knows, a lot of the stuff I'll talk about, I've intentionally set it up so I think these will mostly be good things to know regardless of where you end up going. So that's kind of my hope here. And let's see, make sure this is synced up. Yep, I think we're good.
Fernando, I like how you're always eating on these meetings. I appreciate that.
I mean, it's always during my lunchtime, so and I have a meeting right after this one at one from 1 to 2, so I have to.
Oh, it's great.
I should have brought my lunch then. My schedule got all blown up, so I haven't eaten yet. So
Well, feel free. I don't know. This is a pretty casual group. I think
okay.
we're cool with anything.
All right. So first, is my screen share working?
Yes, it is.
Okay, excellent. Let me let's see this thing. Oh, we're okay, I think. All right. So are we ready? Are we waiting on a few or
Nope, take it away.
all right. So I am Dr. Jacob Hauenstein. I'm an assistant professor at UAH, which I'll talk about on the next couple slides. But yeah, as I said, so basically my goal with this is ostensibly I want to talk to you about data science at UAH. So that's going to include a little bit about the courses, a little bit about research projects we've had in the past, some that are still going on. Um, but as I mentioned, my hope is just going to talk a bit about research generally and a few other things. In fact, I'm getting ahead of myself. This is in my overview. And my hope is that most of what you'll gain here is applicable regardless of where you go. I mean, we'd love to see at UAH, but if you decide to go somewhere else, hopefully there's something here you can take away. So yeah, to start with, I'll give you a little bit more about me and what exactly I do at UAH. Then probably most of you know this, but in case we're not on the same page, I want to talk about what exactly I mean when I say research, at least from an academic standpoint. Why I think it's useful for students, especially undergraduates, since most of you will be undergraduates. Um, and then I'll get into some specific data science work that I have done at UAH and that other people have done at UAH, and then I'll get into some other stuff. So as I already said, I'm an assistant professor at UAH. So I actually got my degree, my PhD degree from UAH also in 2020. And so my work, my big research work, my dissertation there used a lot of medical data, like from CT scanners, and combined that with what's called differential geometry, which is, for those that don't know, that's basically the combination of calculus with geometry. I always planned on going into academics. That was kind of my goal ever since I entered the PhD program. Unfortunately, I got done in 2020, which it turned out to be, we'll call it an exciting time. So I actually got done right after the pandemic started, but I had started interviewing right before the pandemic started. Um, and then by the time I was looking at taking jobs, basically everything had started to shut down. So even though my grand plan was to go somewhere else, which is sort of a tradition in academics, you usually don't stay where you graduated from. I decided moving during the pandemic was going to be awful, and UAH happened to be hiring, so I put in my application there, and I've been teaching at UAH, professor at UAH, ever since the fall semester of 2020. Um, my research interests, and I'll come back to these again. Historically, I considered myself a computer graphics, computer visualization person, along with image reconstruction. I've since I've started, leaned more into data science and also things like data archival, data warehousing, data recovery, which of course have tie-ins to data science as well. And just, is there anything I need to see in the chat? Okay. Everyone can hear me, right? I haven't dropped off.
Yeah,
Yeah,
no,
you're
we
good.
can hear you.
Okay, okay.
And I'm watching the chat.
Okay, okay, excellent. I just, my headphones disconnect or something. I may not be able to hear you either, so I'm not, but all right. So what I do at UAH, and more generally, I'll get into what professors typically do. And this I think is pretty typical. So what I do at UAH is for each semester, I'll teach about 2 courses. So lately, they've had me teaching courses like our data mining course, which is a graduate level data science course offered in my department, the computer science department. This upcoming semester, I'll be teaching our survey of artificial intelligence course. I've several times taught our computer graphics course. We have a video game design course, which I'll be teaching in the upcoming fall. So any given semester, typically I teach 2 courses. In addition to that, I advise graduate or what are called jump students, and at the end I'll come back to what I mean by jump students. So what I mean by advise is if I have a student who's doing research, I basically help guide them and help them figure out what they should work on. You know, if they get stuck on a problem, I say, why don't you try this? Things like that. And so that's for thesis and dissertation students. So that is master's and PhD students. And for students, whether they're doing research or not, I basically help them figure out what classes to take for graduate students. I sit down with them and say, well, what are you interested in? What classes do you need to take and all that stuff. And then I also do, of course, research. So as I already hinted, I do a variety of AI ML work. I do visualization, all kinds of stuff like that ongoing. And for my research, nearly all of it involves a mix of undergrad and grad students. There are a couple small little projects I just go off and do by myself, but almost always when I say I'm doing research, there are graduate or undergraduate students involved. Yep, here we go. All right. So for those not familiar with exactly what we mean by research in academics, I mean, the term research itself pretty much means probably what you think. You're trying to solve previously unsolved problems. You're trying to solve existing problems in newer, better ways than the last person solved it. You're maybe doing studies where you do comparative analysis. I've done tons of comparative analysis over the years. Well, I'll look at different previous problems and compare them and see, you know, this one runs faster, this one's more accurate, things like that. And the way this usually works, at least at universities like UAH, the university essentially gets paid to solve problems, and the faculty get paid to solve problems. So the form this takes is a professor will sit down and say, I have an idea, and they'll write it up and send it off to the National Science Foundation or some other group. Or sometimes some group will approach and say, hey, do you think you know how to solve this problem? And so you'll write up and say, I think I know how to solve that problem. And then basically that funding organization like the National Science Foundation will essentially give a hunk of money to UAH, who then basically distributes it out to the faculty working on the problem and the students working on the problem. So as a student, you're interested in this because potentially if you got on a funded research problem that you're working on, that can actually pay for your entire graduate degree and also pay you. You can get a stipend as well. And we'll talk about that a bit later. And usually, in order to sort of show that you've made progress on your research, you have to publish something. So you write up a paper and you can send it to either a conference, which you usually have to travel for and go and present it somewhere, or a journal where you don't have to travel, but usually the paper is a little more involved. And we can talk about that later. And so if you like travel, the opportunity to go to conference is pretty nice. First conference I ever went to was in Tokyo. And so that was great. That was actually the first time I'd been to Japan. So sometimes you can get to do some really cool stuff depending on sort of what conference you end up at. So I've talked a little bit about what I mean by research and sort of hinted at what some benefits for you might be. One being you can potentially get your graduate degree paid for, and you can get paid as an undergraduate as well. But there's a lot more benefits to that I think aren't immediately obvious. So one of the things with doing research is you'll get to work typically on larger, more complex, more interesting projects than compared to, say, a semester project in a course or a couple week project in a course. And as part of that, you'll just get in general a lot more hands-on experience. And in the research world, you often get to work with sort of newer technology. Classes tend to have quite a lead time. At universities, there's someone has to propose the class, and the class has to be approved, and then you have to find a textbook for the class. And so as a result, for example, I teach a Unity class, but we're still using the Unity version from 2022 because that's just kind of the way things end up working. Whereas if you're doing research, you don't really have that kind of restriction. A lot of times you can use the newest tools, the newest methodologies, whatever. And as part of all this, you'll get to spend a lot more time learning tools, which is a great sort of thing to put in your resume, right? Like I've spent, hundreds of hours working on TensorFlow or working on whatever as part of a research project. You get to spend more time just working with data. So learning pre-processing methods, all the stuff that you guys have probably talked about. And in general, you just get some nice stuff to put in your resume. So I think research, especially at the undergraduate level, is something that a lot of students kind of sneeze on. They kind of say, "Oh, I want to get my degree. I'll probably be able to get a job." Especially in Huntsville area, the job market's really hot right now. But I do think doing research gives you a little bit of a leg up. You got a couple nice points on your resume that the person next to you in class who's not doing research doesn't have. And as I hinted before, research can potentially pay for your graduate degree and also pay you. So we'll talk, I think, towards the end about graduate research assistantships. And graduate research assistantships are typically quite competitive. So there's an application process at whatever university you go to, and basically your resume gets put into a pool, and professors will go and say, "I think that person would be a good GRA for me." So if you've already done research, that means you've already got research experience. You already know about the general process. You already know some of the professors potentially who are doing research. So even at the undergraduate level, doing research can pay dividends at the graduate level because basically you've got, again, just like with the job market, you've got kind of a leg up. I forgot to mention at the outset, by the way, I've got QR codes embedded randomly throughout here. And these are also links. I'll send out the slides and you can distribute them to the students. But that QR code should take you to the UAH website about graduate research assistantships. So then another obvious question is, suppose I've sold you on doing research. You think, okay, I want those resume items. I want that leg up on grad school. How do I get started doing this? One of the biggest things, in my opinion, is while you're an undergraduate, just ask, just talk to your professors. As a professor, I am well aware that many of my students really just want to get their degree, go get a job, and be done with it. And they don't want to think about anything they view as extra effort, extra work. So if you're someone who's interested and willing to do research, just talk to your professors. Ask them, what are you researching? Do you have any openings for, say, undergraduate researchers? Talk about what experience you've got. If you've worked with AI frameworks, whatever it may be. And that really helps you kind of get your foot in the door because it's a bit unusual that a student's actually interested in what the professor's doing, to be honest. Most students, they come to class, they do the work, but beyond that, they say, well, I'm going to get my degree and go get my job, and I don't care. So you can really make yourself stand out just by asking. Other things to look into, there's a nationwide program called Research and Creative Experience for Undergraduates, often called RCEU. That QR code there will take you to the UAH RCEU website. And that is a great way to get in. So the way RCEU works is essentially professors from all over the country will come up with basically proposals for things that they would like to see undergraduate students research. It'll be a specific idea working in maybe a specific laboratory or with a specific set of data and so forth. And then essentially students can just go out and find those and apply for them. So 2 summers ago, I did this and had a great student who got a lot of great progress done, and I think gave himself a great opening for graduate work, graduate research. So RCEUs are definitely something to look out for. That's as an undergrad. If you're a grad student, if you've done research before, you kind of have an opening. But if you didn't do research as an undergraduate and you want to start, you want to do a research graduate degree, still just ask. Other things that you can look at are, I already mentioned, apply for a graduate research assistantship, a GRA. And then basically that'll go into the pool and all the professors can look and see, hey, that person has experience I want to see. And they can pull you out of the pool and hire you and hopefully pay for your degree even, or at least a semester or two. So that's another great thing to look at are GRAs. So that's kind of my thoughts on the value and how to kind of get going on research, mostly for undergraduates, but some of which is applicable also as you become graduate students. So now I want to talk a little bit more specifically about things that I and others have worked at UAH. So my research interests I already called out are computer graphics, visualization, image processing, and reconstruction, and so on. So a few of these hit probably with your own interests of data science, but one thing you will see as I get into this is these days, just about everybody, at least in my department, every professor does something that has some connection to data science. Part of which is, you remember I talked about funding for research. Well, there's a lot of funding for data science research right now. So even people who maybe never thought of themselves as data scientists, which honestly I historically didn't directly think of myself as a data scientist, are starting to think of themselves as data science because there's a lot of funding opportunities, there's a lot of great research opportunities in that area. So I'll tell you a little bit about a couple projects that I personally have worked on with undergraduate students. So one I'll call robust visualization, and one I'll call data warehousing and data recovery. So we'll start with the first one there. So the idea with robust visualization is, I'm sure everyone there is aware that visualization is a huge part of data science, right? Like you often want to visualize your data before you process it. After you pre-process it, you want to visualize your results, right? It's a big part of inspecting, understanding, and knowing your data is the visualization kind of workflow, right? But of course, visualization is just used everywhere else too, right? Like even say digital car dashboards, right? Like a lot of cars now are getting away from the actual physical little needle speedometer that moves, and they'll actually just have a rendering. They'll have an LCD or some other display, and they'll just have a rendering of a speedometer, a rendering of a tachometer and other things. And the same type of thing is happening with airplane cockpits. They are actually replacing the traditional indicators with one or two just big screens that just render the indicators. So we may not think of that as part of data science, but that actually is. That's visualization. It's just a different use of visualization. So what I mean by robust visualization is I'm thinking specifically about things like these car dashboards and these digital airplane cockpits, digital car dashboards and digital airplane cockpits. So the idea here is to make those visualizations robust. And by robust, I mean these visualizations should work. Basically, I mean, you should be able to read them, right? You should be able to see what data is being presented to you on the speedometer and so forth in adverse conditions. So adverse conditions could include like the display has partially failed. So like, for example, the right-hand side of the display no longer works or is covered up. So this may come up, for example, like a military aircraft or really any aircraft if you've got a lot of turbulence, or especially military if you're coming to a firefight or something, a portion of the display could be damaged. This also could be because environmental issues. So if you have really intense vibrations, if you have a cockpit filled with smoke and you have to put your mask on, it may be really hard to read the digital display through the smoke. If again you're in the military, you end up in a firefight, maybe the pilot has a concussion and the pilot's vision is not working quite right. Is there any way we can make the display, the visualization more readable in in that case. So I approached this problem because I personally just thought this was an interesting problem, because if you think about kind of the world of visualization, the state of practice, how things are typically done is we just always assume that everything works, right? The display is going to work. The room's not going to be filled with steam. It's not going to be filled up with smoke. The display's not going to be vibrating uncontrollably. But when you talk about environments like military aircraft, especially, or just general commercial aircraft, you talk about cars, a lot of those things aren't necessarily guaranteed. And even more so, it's really a problem if the display fails, right? Like if you're out in the middle of nowhere in some military aircraft and there's a partial display failure, you probably don't want to just turn around and go back to the parts depot and have some tech put in the new display, right? You'd really like to continue as much as possible. So that's kind of the idea. And my thinking with this also is this idea of visualizations that continue working is likely to be very important going forward. So there's been this trend in general where we present people with more data and have them make faster decisions, right? This is kind of the whole idea with things like AI co-pilots. And so you'll even see if you look through calls for funding, which probably none of you do, but if you look through calls for funding, you'll see all sorts of military calls where we want to create an AI co-pilot to help pilots make split-second decisions and stuff like that. So there's even more of a push to have more data presented and have it help people make really split-second, potentially life-changing, important decisions. So this raises the question of, okay, what if I can't see some or all of my data and I need to make a decision right now? How can I deal with that? And so this is going to be important everywhere we've got digital displays: aircraft, automobiles, medical equipment. And another thing that's been happening as aircraft and other vehicles have moved to this digital display is they've actually replaced what was traditionally multiple separate indicators, right? Like you had your altimeter, which was separate from your other things. And they've combined those into one thing, one single display. So that means we've now moved multiple points of failure to a single point of failure. So one single damaged display, I can lose 4, 5, or 6 important displays. So that's another reason I think as that trend continues, more and more cars have just simple digital displays instead of multiple analog traditional displays. I think this type of thing is going to be more and more important. So I had a couple undergraduate students work on this problem, basically based on kind of just this idea. So this was just a mock-up that I had made where it essentially shows a made-up, this isn't actually modeled after any specific model car. This is a made-up, just hypothetical digital dashboard. And so we can see here that if, let's say, something happens and the right-hand side of the display quits working, we get what's at the bottom. And so in this case, we've lost our speedometer, we've lost our temperature indicator, are probably the most important things. We've also lost any indicator lights that happen to be on that side of the dashboard. So the question then is, if I've got a portion of the display still works, is there some way I can build a system that, one, automatically detects what portion, if any, of the display has failed, and two, automatically moves everything important over to just the functional part of the display? So for example, here we would probably want to move the speedometer over to the left-hand side and maybe get something like this. So what can we do about it? Well, one option is we can detect which part of the display is still working, and we can move over anything important. So here we decided the map's not important, so we do want the temperature indicator, we do want the fuel indicator, we want the speedometer, and we want the tachometer. So we combine the speedometer and tachometer, and there you go. You have all your important data on the remaining still working part of the display. Unfortunately, this is just a mock-up. However, what my students were able to do was basically something very close to what we hoped for with that mock-up. So I had 2 undergraduate students working on this problem, and essentially it was a multi-part effort. One student worked on basically developing simulated cockpit displays and simulated car dashboards. And that dashboard was capable of basically getting input from a sensory mechanism that the other student was working on, which actually turned out in this preliminary case to just be as simple as a camera pointed at the screen, that essentially using QR codes can detect failed regions of the screen. And so one student worked on a component that was able to basically reshape the display to avoid failed segments on the display, failed regions on the display. And the other student developed something that is able to detect which regions have failed and basically pass that information back in real time to the display component. So my undergrad students actually were able to go present this. I think the conference was in Orlando. They had a really nice paper they put together. And both those students, in fact, have continued as graduate students in part based off this work that they did as undergraduates, which again is why I'm suggesting that starting research as an undergraduate is probably a very good idea. So another thing that I have worked on is in the realm of, we'll just call it data warehousing and recovery. So this ties into the big data movement, specifically in the world of data science, specifically machine learning loves big data, right? So there's this push to basically archive everything. So we can train machine learning models on it, right? We can train large language models on it, right? So we've been seeing this push to archive and digitize data for a long time, with people scanning entire libraries of books and so forth. And part of that, of course, is for preservation purposes. You know, what if the library burns down? Then, well, you want to at least have a digital copy of the book. So archiving and digitizing all this data, of course, can be difficult. So even if we restrict ourselves to data that's already digital, like data on, for example, CD-ROMs, if we want to archive that data so we can point a machine learning system at it, for example, we've got to somehow read all that data, right? Plug it into some big database. Well, one of the problems that arises here is a lot of digital data is really old at this point. It's on media that is degraded, it's damaged, you know, it got wet, it got scratched, it got whatever. So for example, if we want to sit down and digitize CD-ROMs, there are CD-ROMs that are 40 plus years old. So things don't age well over that duration, right? So there's a lot of CD-ROMs out there that people would like to archive the data from, but they're degraded from time, from being out in the sun, and so forth. So the idea with this project was we wanted to recover data from old damaged CD-ROMs. And the way this worked, oh, and by the way, I had another project, which was actually a rare one I worked on my own, but I also have I did some work on data compression, specifically targeting data archived from CD-ROM. So that's an area that the department has done some work in as well. But the idea here is, so we targeted CD-ROMs partly because those are typically the oldest media around. I mean, there were things that predate that, but CD-ROMs were when people actually started having in mass digital data. And they're the oldest, so they're the most likely to have been damaged and suffered from aging and all that stuff. So CD-ROMs are actually the standard itself, the 40 plus year old standard is actually really cool. It has lots of stuff built in to help them resist damage and data corruption. There's the ED&C process, they call it, error detection and correction. And so there's a lot of sort of, call it, baked in ways for the data to avoid, or for it to preserve the data. But we're talking about disks that are 40 plus years old. So the ED&C reaches its limits. The way ED&C usually works is your little optical drive that I realize nobody has anymore, but your little optical drive does it itself. So it basically shines the laser on the disk. It does a whole bunch of decoding and error detection and error correction processes. However, that drive has very, very limited memory and very limited computational power to actually execute the data correction and the error detection and correction process. So it turns out with a little trickery, you can actually bypass the optical drive's error detection and correction process and do that error detection and correction entirely in software. And the advantage here is that if I can just get the raw data from the drive, um, without the drive interfering at all and saying, oh, I refuse to give you that data because there's errors in it, which is basically what drives do, then I can get the opportunity to have the computer, the host computer, which has, you know, thousands of times more memory, thousands of times more compute power. I can have it try to do the error detection and correction. And so this required an undergraduate student who wrote some custom software. There's basically a little bit of trickery you have to do to get the uncorrected data. It's actually technically you're not supposed to be able to do it actually, but it turns out there's a bug essentially in some optical drives that let you do it. So he wrote some software to basically trigger that bug and get data from the drive and do some other things. So basically, what that undergraduate student did was, and this was an RCU project, by the way. So this was over the course of one summer. He designed an algorithm that implements all of the stuff in software. So he went and read through the compact disk data storage standard, read about how the error detection, error correction stuff works, implemented what uses the Reed-Solomon codes, the RS codes in software, and did all this stuff in conjunction with writing code to bypass the error detection and correction on the drive and allowed him to do all of this detection and correction on software. He also, as part of this, developed visualization tools for the results. That screenshot didn't really come through, but that's actually his tool that's color coded indicating which sectors work. And so that helped him sort of keep tabs as he was inspecting disks to see which sectors, basically which bytes you could get off the disk successfully and which you couldn't. And so what he found was that, in fact, you can, for certain types of disks, actually manage to correct more errors using a software approach than you could with a hardware approach. And so this is what he found was typically the number of errors in the experimental case was close, but usually lower than in the control case, which is where you let the drive do it. And so this was just, he had a collection of damaged disks that he was looking at, and this is just, these were selected basically randomly. And overall, there were some disks that the drive did better. There were some disks that the computer, so his approach worked better. But at the end of the day, what he ended up with was a really nice framework to build on. And so it turns out that there exist networks, neural networks, adversarial networks for doing Reed-Solomon decoding. So probably he's got a master's project when he graduates that he can think about doing where he can leverage what he did here in the RCEU and work on improving these results using things like adversarial networks and other machine learning approaches that weren't employed in the initial undergraduate effort. So that is just a couple of the things that I have worked on. Let me tell you a little bit about generally what goes on in the computer science department at UAH. This is my obligated sales pitch to tell you about UAH. So we have, it turns out I was going through the faculty in the department, and I think most people, as I hinted at earlier, do something related to data science. So we have Dr. Manon does lots of big data analytics, does data compression. We have Dr. Tim Newman does computer graphics, visualization, automated inspecting, image processing, high performance computing, that should say, all of which tie into data science. Dr. Chung does visualization, human computer interaction, which of course tie into data science. Dr. Zhang does deep learning, lots of theoretical machine learning work. He has his graduate degree, I believe, is actually in mathematics, so he's a very theoretical mathematics person. Dr. Joshua Booth does lots of high performance computing that relates to data science and so on and so forth. And I think you'll probably find something similar at any research institution, is if you go and look at their computer science department, or even some of their other departments like computer engineering and so forth, you will probably find lots and lots of people. If you dig through and look at their bios and things on the website, lots and lots of people are doing things that tie into data science. And you'll see, as I kind of hinted before, even people who are not listed as data science or AI or machine learning or whatever people are often doing something that ties into data science. So we have 3 professors in our department here who ostensibly do cybersecurity is their main area of interest. Doctors Mukherjee, Brizendine, and Zhu. However, if you do a little digging, you will find that even those people who don't declare themselves to be data science often use AI and machine learning as part of their cybersecurity research. And I've got some examples that Dr. Frank Zhu, was kind enough to share with me that I'll talk about very briefly. I'll kind of blow through these on the next few slides. So Dr. Zhu has been doing a lot of work essentially that tackling the human component of cybersecurity. That is basically coders writing insecure code, people essentially not paying attention to what they're doing. So he and one of his graduate students actually developed a deep learning based approach for detecting essentially if your mind is wandering using an EEG. And so there's all kinds. It turns out we spend about half our awake time with our mind wandering. So it's pretty common. And you can imagine if you spend half your time, some of that time is going to be when you're at work, we're supposed to be writing secure code or whatever, right? But so essentially they were able to use this electroencephalogram EEG machine in conjunction with a deep learning model to extract features. They were able to basically detect when your mind is wandering. So they built the system that kind of looks like this, which this wasn't my work, so I'm not going to talk about it too much because I don't know the details too much about it. But this essentially is the idea. So you can see there's lots of, even though this is billed as cybersecurity research, you can see a lot of things in here that tie into data science, right? Pre-processing. Pre-processing falls into, you talk about that in data mining, you talk about that in other data science courses. Downsampling, you talk about that in all kinds of data science contexts. Creating topographic maps, well, that's visualization, that's data science. Using a pre-trained network as a feature extractor, well, that's machine learning stuff, that's data science. So even though we're here tackling a cybersecurity problem, almost like 95% of it, you could say, is data science problems, right? So anyway, they were able to get pretty good results with that. Another work that Dr. Zhu has done is tackling, again, the human component of cybersecurity, is analyzing and visualizing what processes developers go through when they are doing secure code. So that is either writing code or fixing code that has been reported to have security issues. And so, of course, very important area. But basically what they did was they developed a coding environment where people could work. They brought people in and they had an eye tracker as part of this. Somewhere in here is the heat map. Just a second. Oh, did I not put the heat map in here? Oh, maybe I don't have the heat map. Anyway, there's a heat map where basically they use the eye tracker to figure out sort of which lines of code and which particular things within the line developers were looking at. And so what they did was they had examples that had known security issues. They knew exactly what line it was, and they knew exactly what the problem was, and they knew exactly different ways to fix it. And so basically what they did was they used an eye tracker, they sat people down, they had them try to fix the code, fix the security issues with the code, and they analyzed sort of what are they looking at to try to get an idea of what are people getting distracted by. Is it they're distracted looking at other things in the IDE, or what exactly is going on? And so they were able to sort of come up with some guidelines that potentially can help people in writing secure code. And again, this is a big time data science problem, even though it's cybersecurity, right? We've got all this visualization stuff, all this analysis that I'm not going to go into, but different ways of visualizing it, swim lane representations, all kinds of stuff. And so they have state diagrams that show exactly what everybody did. Again, visualization, right? Firmly in the realm of data science. Pupil diameter, that gave them information about what people are concentrating on and things like that. So all kinds of stuff. So one, I guess my kind of takeaway with this line of thinking is, even if you're in a cybersecurity class or something and you're thinking to yourself, well, I want to do data science research. So you're thinking, maybe I don't want to talk to this professor, because I don't want to get into cybersecurity research. Well, data science is everywhere. So my advice would be to talk to everybody if you're interested in doing research. See what they're working on, because you'll probably find something that ties into data science, almost certainly. All right, so I want to talk now a little more specifically about the data science options you have at the University of Alabama in Huntsville at UAH. So we offer a data science concentration at both the undergraduate and graduate level. So the degree itself is a computer science degree, but there's a concentration. So that is a specific sort of set of courses you take that are data science courses. And so that will give you a degree that actually notes data science on it, or the certificate that actually notes data science on it, rather than just being computer science, or at least you can say anyway that you had a data science concentration. The degree itself might actually just say computer science. I'm actually not sure. We also offer data science certificates. So for those that don't know what certificates are essentially not a degree. So it's not in a degree program. You have all the general education requirements, right? You got to take the English lit classes, you got to take the history classes, and all the traditional stuff. And so you come out and you've got sort of a traditional university education, right? A certificate is basically if you just want classes on a specific area, but you're not awarded with a degree. So you can't say, oh, I have a bachelor's degree or a master's degree or whatever. But you get a certificate that basically says you completed all these data science courses satisfactorily. And so, depending on where you work and so forth, the certificate can get your pay bump and things like that. As I already said, there's lots of faculty doing data science research. So the top QR code here, by the way, links to the relevant section of the catalog that talks about the data science concentrations, the data science certificate. The bottom QR code here is a link to the faculty list, which I sort of already gave you a summary of a lot of what we're up to here in the computer science department. If you follow that QR code to the data science to the catalog, you'll see there basically the summary of what makes up the undergraduate and graduate data science concentration. So there you can see the survey of artificial intelligence, which is actually a course I'm teaching in the fall, big data computing, and then you get to select from some other courses, including modeling and simulation, cloud computing, database systems, and so on and so forth. Something that may be of particular interest to this group is UAH offers a thing called the JUMP program. So what the JUMP program offers is essentially a 5-year combined Bachelor of Science and Master of Science degree program. So the way JUMP works is once you meet the JUMP requirements, which I'll talk about in a minute, it lets you take up to 4 graduate courses while you're still an undergraduate. And there's a few big benefits to this. One obvious one is that you can get your Master's of Science sooner, right? Because you've already knocked some courses out. But another big benefit is graduate courses typically cost more unless you take them as a jump student. If you take graduate courses as a jump student, you will pay the undergraduate tuition for these courses, which is substantially lower. And at UAH, you will be allowed to count those 4 courses toward both your undergraduate Bachelor's of Science and your graduate Master's of Science degrees. Another thing is if you meet the GPA requirements at the time you complete the JUMP program, then you will automatically be accepted into the Master of Science program at UAH. So you won't have to go into the big applicant pool and they pick you out and say this person looks good. It's automatic. You're in. I believe, unless they've changed it, I think you also avoid the application fee. So for those that don't know, a lot of graduate schools have application fees. You will not have to pay an application fee, I believe, if you do the JUMP program and apply to UAH. And of course, you get your Master of Science sooner. So that QR code, if you want to read about the JUMP program, that will take you right there. A little bit about scholarships, particularly those relevant to data science, but also just in general. So the way scholarships work at UAH, and it's going to be pretty close to the same, most likely, no matter where you go. UH has tons of internal scholarships. So that is to say, essentially, someone has donated some money to the university. Sometimes an individual, oftentimes a company. Oftentimes it can be from someone's estate when they pass away, for example. And so basically that money gets set aside for scholarships. And so UAH has tons and tons and tons of these internal scholarships where people have donated money for the purpose of giving students scholarships. They on the UAH website, they split them into academic merit scholarships. So these are basically if you got high grades and have high standard test scores and so forth in high school, then you can qualify for academic merit scholarships. And the way it works at UAH is you will automatically be considered for any merit-based scholarships if you're accepted. They will just go through and look through your high school transcript and see whatever you qualify for, and you'll be notified. And I think you have to go in and click accept. They'll send you like an email, and you have to go in and accept the scholarship. There are also competitive scholarships. So the way these work is it's not specifically based on any one criteria. It's based on some variety of criteria, typically based on whoever donated the money, what they want. So they can give money, a company can give money and say, you know what, we need more data science students, so we're going to have a scholarship specifically for data science students. But it also could be we want people with leadership qualities. So there could be scholarships specifically for people that exhibit leadership qualities and things like that. So the competitive scholarships are kind of all over the place as far as what the actual criteria are. Some of them are limited to College of Science, College of Engineering. Some of them are university wide, all kinds of stuff. So you will not be automatically considered for competitive scholarships at UAH. We have a separate, it's like a unified application that basically you submit the scholarship application. It's not, you don't say, I'm going out for this scholarship. You just submit a scholarship application and they consider you. And I think that if you look through a little bit from that QR code, there's a list of scholarships. Unfortunately, it doesn't really give you a description. It just gives you the name. But you can see there's like, I don't know, there's hundreds or thousands of them. There's so many. So those were just internal scholarships that I talked about. There are also, of course, external scholarships, outside scholarships. So that is people who have no connection specifically to UAH who just offer money for scholarships. So even though these outside scholarships don't have any connection to the university you're going to, one way to find them is ask the university. There are people at the university whose job it basically is to find scholarships that students might qualify for, outside scholarships that are not directly tied to the university. So, for example, it's been a long time since I've been an undergraduate. I don't advise undergraduates, so I didn't know. Okay, what are some current outside data science relevant scholarships? So I asked our administrative assistant in our computer science department, and she sent me a list. So there's again, I'll send these slides out, and there's some links. So one thing I would strongly encourage you to do is just ask the university. What outside scholarships do you know about? Exactly who you need to ask is going to depend on the university, but it should be pretty easy to find somebody who knows who you need to ask. And they will most likely be more than happy to share with you any details they have about outside scholarships. So I can take some questions after this, but first, let me just tell you what I told you. So in a nutshell, your professors are probably doing research. So there are universities where that's not the case. Teaching universities, a lot of times you call them where professors only teach. But if you go to a research school, which many, especially state schools are, ask what research they're doing. And in my opinion, as both an undergraduate and a graduate, you probably should do research. I think probably nobody ever didn't get a job because they did research on their resume. It's also just great experience. It can give you a leg up, even if you got the same job you would have gotten otherwise. You have a little more experience under your belt, and it can help you out. UH specifically, we've got tons and tons and tons of data science options. Much of the computer science faculty has some connection to data science in some shape or form. A nice opportunity, especially for people extremely interested in data science, is the JUMP program, because the JUMP program will let you take our more advanced graduate data science courses as an undergraduate. You do still have to meet the prerequisites and some other things. And there's a grade level requirement and some other things. But it does let you jump into some of those courses a little bit earlier. And I would encourage you to look for both internal and external or outside scholarships. And you'll have to, for whatever university you decide to look at, you'll need to read up on the application process. They probably have their own application process for the internal scholarships, and then all of the outside scholarships are going to have their own specific process you have to go through the essay you need to write or whatever. So that's what I've got. Any questions?
With the JUMP program, would it be better if you're inside honors college when trying to go into the JUMP program?
So the JUMP program is typically actually not extremely competitive, interestingly enough. So it certainly won't hurt you, but the way the JUMP program works at UAH is typically if you meet the requirements, and so for the requirements depend on what your major is. So for computer science, we have an overall GPA requirement, a GPA requirement specific to your computer science courses, and we also have some specific courses you need to have taken. We have to take our 300 level algorithms course before you can apply. As long as you meet those requirements, if you put in an application, in my experience, you will be accepted. The only time I've seen students not accepted are because it turns out they submitted right before they completed that course, or their GPA wasn't as high as they thought it was, or something like that. Does that answer your question?
Yes. Well, I'm planning on going to cybersecurity, or I'm considering between a cybersecurity and computer engineering, and yeah, I just maybe something more specific about that.
Yeah. So, I mean, so to be clear, one thing I haven't mentioned, you probably already know this, but JUMP is a university-wide. So if you go into computer engineering, you can apply for a JUMP through computer engineering. If you go to computer science, if you do cybersecurity, so UAH actually has multiple sort of ways you can do cybersecurity. So if you're a computer science cybersecurity student, then you can go through computer science JUMP. If you're computer engineering, you can go through the computer engineering JUMP. And depending on what department it is, you have different advisors you have to talk to. So you have to go. I'm a JUMP advisor in the computer science department, but I can't handle any, for example, computer engineering students. But I do know that university-wide, essentially, as long as you meet the requirements, in my experience, you will be accepted. So as soon as you meet the requirements, you can go ahead and meet with the JUMP advisor. They'll help you talk to you about how you fill out the form. And basically, once you get it in, then you should hear back a little. I can't remember how long it usually takes, but you'll hear back. And basically, from then on, you can take the courses that you noted in your JUMP form. So you specifically list what courses you want to take, what graduate courses you want to take, and then once you're approved, then you're allowed to sign up for those courses.
Okay, yeah. And then there's also with the undergraduate research, when it comes down to like, do you know anything about any like is it any programming like cybersecurity kind of projects that anyone has done?
Yeah, so there are lots of undergrads working on cybersecurity projects. We also have, I actually realized I told you I was going to tell you about the clubs and I forgot to do it. So we have a very active cybersecurity club. So especially anybody interested in cybersecurity, I would strongly encourage you to look at the cyber club. They actually, I meant to put a link to it, but we've got a banner hanging out in the hallway right now for the some of the big competitions that they've come away winners of. So that we've had a very successful, very good cybersecurity club. So one thing that I would encourage everybody to do is, if you come in knowing, okay, I'm interested in this, see if there's a club that targets that, because that will give you basically a lot of exposure to other people who are working in that area. You'll get to talk to professors, you'll get to learn about research projects, who's working on the research projects, and all that kind of stuff. So cybersecurity is not my area, so I don't know specifically what undergrad research is going on there, but I can guarantee you that there's lots of it. There is lots and lots of undergrad research going on at UAH.
I have a question. With the
Yeah.
research in the undergraduates, how soon do most undergraduates tend to start taking on research? Or when is a good time to start taking on research in your undergraduate?
So it's is not kind of not a one size fits all. So my students on my most recent project started when they were juniors and continued when they were seniors, and then continue as graduate students. And I would say that's probably one of the most common is a lot of students, well, a lot of professors kind of, if you're a freshman or a sophomore, they kind of maybe incorrectly, they may think, well, you haven't had the really hard classes yet, so do you really know what you're doing? Kind of thought. But it depends on, like, it could happen to be the case that a professor's looking for someone to do improve the performance of some, say, TensorFlow code or something. And maybe you had a big project you took on in high school as an internship or something where you did exactly that. So I would just mention that to the professor, and then they may say, well, I don't care if you're a freshman, it sounds like you can do it.
All right, thank you.
Sure.
I have a question about the JUMP program. So, when is the typically where students applies it during their sophomore year? And also to implement that to the JUMP program to your bachelor's, how does that work for your, I guess, your courses and taking classes like that?
So it varies by department. So for my department, as I mentioned, you have to have successfully completed our 300 level algorithms class. So usually people view 300 level courses as junior courses. You can, depending on sort of how you set up your schedule, you could potentially end up taking it earlier on. So there's no specific rule. However, it typically would probably not be when you're a freshman, because you won't have been able to complete 317 by then. But to my knowledge, there's no specific rule from the university that you have to be at least this grade level standing. As long as you meet the requirements, you can take it. You can go for it. So regarding the courses, so the way the courses work are, so some of our courses have both a undergraduate and a graduate version of the course. So for example, I'm teaching a course in the fall, our survey of artificial intelligence course, that works exactly that way. There's a course numbered 430, which is the undergraduate version, and a course numbered 530. At UAH, the 500 and up courses are considered graduate. And so the way those specific courses work is you actually will sit in the exact same classroom, whether you're an undergraduate or a graduate student. But if you take the course as a graduate student, you will have a bit more coursework. Your exams may be different and harder from the undergraduate students. You may have an extra project, for example, compared to the undergraduate students. And so a lot of JUMP students prefer to take those style courses. So for example, we have a course just called programming languages that every computer science student is required to take. Well, there's also a graduate version of programming languages. So what students can do is they can say, well, I'm gonna use that as one of my JUMP courses, and I'm going to take the graduate version of programming languages. Well, what happens then is that course simultaneously meets your undergraduate requirement to take a programming language course, and also will be counted as an elective course, an optional course for your graduate degree. So that will go towards your number of credit hours you need for your graduate course. So that's what a lot of students do, is they'll just find courses that they were going to have to take anyway, and they'll take the graduate version of it. And that lets them have some elective courses that they don't have to take later on when they're in grad school. But you're allowed to take any course that you meet the prerequisites for. So, for example, we have a graduate version of our algorithms course, which is required for anybody getting a master's degree in computer science. I have had a number of students who said, well, I want to, once I meet the requirements, take the graduate algorithms course. And so what happens then is that counts as a required course for your graduate degree, and it counts as an elective course for your undergraduate degree. So that's in general how kind of it works. So and you could theoretically have a course that counts as an elective both for your undergraduate and your graduate, but a lot of students use it to get out of the way courses that are required either by the graduate degree or by the undergraduate degree. And so in one program it counts as an elective, and in the other program it fulfills a requirement. Does that answer your question?
Yes, it does. I also have another question. Does UAH have any degree in artificial intelligence or any research based artificial intelligence that goes on at UAH?
We have tons and tons of research in the realm of artificial intelligence. We do not have a specific degree that says artificial intelligence. You can, as I mentioned, get the data science certificate. So we kind of just roll artificial intelligence broadly into the data science area. So if you look at the data science concentration at either the undergraduate or graduate level, one of the running themes is that you will take a number of artificial intelligence or machine learning courses. But to my knowledge, we don't have any degree that specifically says artificial intelligence. But that being said, a lot of the data science people are doing work in all variety of artificial intelligence. We've got people doing using large language models to develop models to help people find rural healthcare coverage. We got people doing all kinds of cool stuff that while even if they're not technically, as I said, data science people, they're using data science to accomplish some tasks. So it is not hard at all to find people doing AI research, and be it theoretical. We've got people doing theoretical research, trying to find the next groundbreaking type of neural network and mathematics based approaches. And we've got people doing more practical things, using existing AI frameworks to just develop new cool tasks and things like that.
Well, thank you so much, Dr. Hounstein. I don't want to keep us too long. We're already about 5 minutes over. I do want to say I think this was awesome. I wish someone had told me about undergraduate research. I didn't even know that was a thing until I was really far along in my undergraduate degree. So I think it's really great that you guys are getting this exposure now. It absolutely is an invaluable experience. Even if you don't plan on becoming a professor yourself, I think just being able to solve problems and conduct research in the workplace will help you stand out and, give you a great college experience too. So anyway, just want to say thank you so much. We really do appreciate you being here today. And yeah, this was really cool stuff to hear about. I'm excited. I think just converted our whole cohort to Chargers now.
Well, I'm glad to hear it. So, I'll if I send you the slides, can you distribute them out to the?
Absolutely, yeah. I'll share
and
slides.
Okay.
And I saw your contact information was there. So if anybody has questions, is it okay if they reach out to you?
Sure, yeah, feel free. Yeah.
Okay, that sounds great. Well, thank you very, very much.
Thanks for having me.
All right. Well, y'all have a good afternoon.
Bye, everybody.
Thank you so much.
All right, thank you.
Thank you.
Sure.
Thank you.